Hello everyone, my name is Achmad Daud Ashshidieqiya, and today I'll be sharing something that sounds like science fiction but is becoming science fact. How a groundbreaking genetic tool called CRISPR-Cas9 is transforming the world of biotechnology. We will explore how this tool works, what makes it so revolutionary, and how it was recently used to help bring back the dire wolf, a species that went extinct over 10,000 years ago. CRISPR-Cas9 stands for clustered, regularly interspaced short palindromic repeats, and Cas9 a special protein that acts like a molecular scissor. This system is based on natural immune defense used by bacteria to fight off viruses. Scientists have adapted it so that we can cut, remove, or modify DNA in living organisms with incredible precision. Think of it like find and replace tool for genetic code, where you can search for a specific sequence, delete or change it, and still keep the entire system working.
How?
Here's how CRISPR-Cas9 works. First, scientists create a guide RNA that matches the DNA they want to change. Second, the guide RNA brings the Cas9 enzyme to the exact spot in the DNA. Third, Cas9 makes a precise cut at the targeted location. Finally, the cell naturally repairs the cut, allowing scientists to insert or delete or replace specific genes. This whole process is powered by advanced software tools, DNA database, and even AI algorithms, making it one of the best examples of how information technology supports biology.
Why?
CRISPR is faster, cheaper, and more accurate than older gene editing methods. It's already being used to treat genetic diseases like sickle cell anemia, develop crops that are more resistant to diseases and climate change, and potentially eliminate inherited conditions before birth. But one of the most jaw-dropping applications is its use in the extinction, bringing back animals that are no longer around. Let's talk about one of CRISPR's most incredible applications, the attempt to bring back an extinct species, the dire wolf.
We turn now to that remarkable scientific breakthrough. 13,000 years after the last dire wolf walked the earth, scientists say they've now brought them back. Here's our chief national correspondent back up and with the video tonight.
The dire wolf roamed North and South America during the late Pleistocene epoch, around 125,000 to 10,000 years ago. It was one of the largest and most powerful canids to ever live, weighing up to 70 kilograms with a robust build, large jaws, and a bite strong enough to crush bone. Unlike modern gray wolves, dire wolves were more muscular, had shorter limbs, and probably hunted large prey like bison, mammoth, and horses in packs. However, around 10,000 years ago, the dire wolf went extinct. Scientists believe this was due to a mix of rapid climate change at the end of the Ice Age, the disappearance of its prey, and competition from gray wolves and early humans. For thousands of years, dire wolf lives on only in fossil records until now. In early 2025, a biotech company called Colosal Bioscience announced the birth of 3 genetically engineered pups, Romulus, Remus, and Colosal. These pups were not cloned dire wolf, but genetic hybrids created using CRISPR-Cas9. Here's how it works. Scientists studied DNA from dire wolf fossil and identified more than 20 genes linked to key physical traits. Using CRISPR, they inserted those genes into the embryos of gray wolf. The edited embryos were implanted into surrogate domestic dogs. The result? Living pups that closely resemble dire wolf in appearance and structure, marking the first major step toward functional de-extinction using gene editing technology.
تكنولوجيا
Why is CRISPR-Cas9 so powerful? It's highly accurate. It edits only the intended genes. It's fast and efficient. Results come in weeks, not years. It's cost-effective, much cheaper than previous methods. It's backed by digital tools. Software helps design, edit, and predict outcomes. Its ability to integrate with AI, cloud platforms, and massive DNA database make it a perfect example of IT enabling breakthroughs in life science. Of course, CRISPR isn't flawless. It can cause off-target effect, meaning the wrong gene might get edited. It raises ethical questions, especially when used on embryos or extinct species. Accessibility is still limited. Not all countries or communities have access to the technology, and reviving extinct species may have unknown ecological consequences. That's why global regulation, ethic boards, and transparent discussions are so important at these tech advances. CRISPR-Cas9 is already having a major impact. In medicine, it could lead to cures for many genetic diseases. In agriculture, it helps us grow stronger, more reliable crops. In conservation, it gives us tools to protect or even resurrect species. But it also brings challenges. Should we use this to design perfect humans? Will only rich countries benefit? What happens when we start changing ecosystem with revived species? CRISPR is not just a tool, it's a responsibility. CRISPR-Cas9 is one of the most powerful technologies we've ever created. It's rewriting how we treat diseases, grow food, and understand life itself. The success of the Dire Wolf project shows just how far we've come and how far we might go. But as with all powerful tools, it's up to us to use it wisely, ethically, and responsibly. Thanks for watching, and I hope this presentation gave you clear understanding of CRISPR-Cas9 and its real-world impact.